We're going to go ahead and configure some OSPFv2 for IPv4 in a single area configuration. I have removed RIP from our previous configuration, and so I've kept the topology as is, but I've just removed RIP from it. I could have left RIP running, and we could have put OSPF in place over top of it, and it would have worked because RIP has the administrative distance of 120, OSPF has an administrative distance of 110, and the lower the administrative distance, the more trusted that route is. So we could have left them running and they would have coexisted. Just the routing tables would have slowly switched over to using OSPF routes, and you would have seen just O's in that code column on the left. But I decided to just start clean, and we'll go from there. But you can do that, and that's relatively common to see. So you may have your company may be running Cisco, and you're running eGrip, and you might have purchased another company, but they're running some other vendor, so they're running OSPF on their network. You'll have a couple routers in the middle then that will run both protocols to hand things off, and you can do that, and that's perfectly fine. OSPF also has the option of running multiple processes of OSPF on itself, and you can do that for navigating multiple areas of OSPF and multiple autonomous systems and such. So that makes it more powerful. But what we're going to do is just stick with one area, one process, just keep it nice and simple. So what we need to do is we're going to go into our main router. We're going to say router, OSPF, and then the process ID number. So you can make that any number from 1 up to 65,535. So that number's come up before. That's relatively common in computers. So I would suggest sticking with 1, and this process number, this process ID, can be anything on any router. You can make it different on every router if you really want. It's just local to that router. But I would suggest making it the same on all of them to save yourself some headache. Because if you keep it all the same, then you'll be able to troubleshoot more easily, especially if you're running multiple OSPFs. So we're just going to stick it with 1 for now. The next thing we want to do is configure a router ID. Remember I was talking about the designated router and the backup designated router for multi-access networks? So if we configure a router ID, that is a 32-bit number. It looks just like an IPv4 address, funny enough. It even has the dotted decimal notation. That will take precedence over anything else that it tries to use for a router ID. So router ID wins first, and the highest router ID will win out of any router IDs that are configured. If there's no router ID that's specified, then the highest IPv4 address on any loopback is chosen. Remember I was talking about loopbacks before and how they're very useful not only for accessing it as a management interface, or if you're on a switch, it could be your management VLAN is your loopback. It's not just useful for accessing that device, but it's used in processes such as this. So that's kind of where I was going with that, was not just to make your life easier, but also because things use it, and you can use that as well as using it as your management address, and it makes your life so much simpler when everything is just your loopback, and you don't have to wonder what things are configured as. But what I'm going to do here is just make a router ID, but if you choose to create a loopback, and you can just do that with interface loopback and then a number, I would suggest going that way instead. And I may create some loopbacks as we go through here, just because, but we're going to go ahead and make a router ID. So and anyway, if it'll choose the router ID, if not, it'll choose the loopback. If there's no loopbacks, it will choose the highest IPv4 address on any interface on the router. So now we're getting into just kind of it's choosing whatever it can find, which is probably the least desirable outcome. So it'll do any interfaces it can find last. So what I would suggest is either define a router ID or make a loopback. There's also one other way of doing it, and this trumps everything else. If you create in an interface, you can define a priority level, and if you have the highest priority level out of anything, then that wins as well, and that trumps the router ID, that trumps the loopbacks, that trumps any interface IPs. The priority will win. So you would do that by going into an interface, and then you would say IP OSPF priority, and then 255 is the highest. So I could go into a loopback even and say this is the highest priority interface if you have multiple loopbacks. So I guess you could do it in that case. That would make the most sense. If you have multiple loopbacks, you could throw the high priority on one of your loopbacks that you prefer the most. But I feel like it's relatively uncommon. But you can define that priority level, and that will take precedence over everything else. I want that to be very clear. But what we'll do is we'll create a router ID. So I'll do router ID, and we'll just make it all 200. So that's nice and high. So this will become our designated router. The other commands, once we're in here, are pretty much the same as RIP. We have basically the same command set, but slightly tweaked. So on this router we have 4 10.networks. So what we need to do is do that network command, and we're going to define those 10.networks. But we're not going to press enter at this point. With OSPF, you have to define the subnet mask. And not just the subnet mask, but it's actually called a wildcard mask. And it's, from a basic level, you can think of it as an inverse of the subnet mask. But it's much more powerful than that, because you can match things that are in the middle of the address and such. It's much more powerful than just an inverse of a subnet mask, so please don't think of it just as that. But and if you want to get into crazy matching and wildcards, you can do that. But for the basics of CCNA, just consider it a inverse of the wildcard of the subnet mask, and it will make your life easier. So what we'll do is define our subnet mask in inverse. So, and actually this was, sorry about that, these 10 dots were /30s, so our subnet mask would be 255, 255, 255, 252, so the inverse would be .3, because if you subtract it out, it'll be .3 to get up to 255 again. If it were a /24, then you would do, like I had typed there, 255. We then need to define what area this is. So with OSPF, I mentioned there's different areas. So not only can you have different different processes of OSPF running on a router, but you have those groups of routers, and those are your areas, so they all communicate between each other. So the most common area that you would have is area 0, which would be your backbone. It's common to have area 0 as your backbone core routing, and then you could have different areas that branch out that might be, you know, different buildings or different locations or something like that. So just for the basics here, we're going to stick with area 0 for everything, but you can have multiple areas, which we'll get into at some point later. So now we've completed our network command. Press enter. We're now sharing and communicating on that network, but we do have to do it for each interface now. Since I'm specifying it this way, I could change the wildcard mask so it does match all 4 of them at once, but I'm not doing that. So we're going to do this. So there's my 4 links that are to the other routers. We can also do passive interface, like I talked about with a RIP. So the problem with doing with these dynamic routing protocols, even with OSPF, is when we define a network, we're defining what networks do I share, and what networks do I share with everyone else, and what networks do I communicate to other OSPF routers on. So it's a double whammy with these network commands. And the problem being when we get up to these routers that are on the outside edge, I'm going to have to say network 192.168.1.0 so that I share that 1.0 network with everyone else, but then I'm also going to start sending OSPF traffic up there, and that's potentially a security concern, it's a waste of bandwidth, and so on. I want to not send OSPF packets that direction, but I still want to share with everybody that I have that network available. So you do that with passive interface. So you say passive interface and then the interface on the router that we want to keep quiet. I don't have to do that on the core right here, so we'll do that on the other ones. But I wanted to just mention that is still there. So at this point, I'll exit out of that, and we'll go into some of the more detailed stuff after I do the basic configs. There's some tweaks that we can do, and I'll get into it in a second. So let's go ahead and we'll continue configuring OSPF on these other 4 routers here. Now on these I'm not going to define a router ID. I'm just going to let them go. I just made the core one with the specified router ID. So I have to define my network. And make sure you append the area to each command as well. And we'll check my passive interface, 0.1. You don't have to do this in this lab environment, but I'm going to anyway. I wanted to actually keep typing to show you that. The other one didn't work because I was in the middle of a command, but if you are just typing from left to right a new command and one of those status messages pop up on your console, you can still keep typing and push enter and it will still work. If I go up, use my up arrow, you'll see the command was perfectly fine. That status message just kind of smacked itself in the middle there. Those are not entered when you push enter. They're just displayed to your console. So it's kind of distracting when you're typing, but when those things come up, you can just ignore them and keep typing your command, and as long as you didn't make a typo, everything will work okay. So I did want to show that. It's probably going to do it again to me. Okay, and we have one more left. Alright, so there we go. So now we have I'm at the central router, so we have our 4 directly connected networks, and then we have our 4 192 networks that are on the switches here that are shared out through OSPF. So it does the exact same thing as RIP in this example, and you can see our administrative distance is at the 110, so it's all looking very good. And this is the cost of the link. So before that was your metric I was mentioning, and that's the number of hops that that it's away. The second number with an OSPF route is the cost of the link, and the way that's calculated is based off of the bandwidth. So remember, at one point I had said, make sure when you set your when you go into your interfaces of a router, set the bandwidths, because things will use the bandwidths. Well, this is one of those things. egrip does, OSPF does. It will check the available bandwidth and factor that into what the best path is. This is what makes OSPF very powerful. It's not just how many hops away, but how far away is it, and what's the fastest link to get there. How much bandwidth is on this link versus that link, and so on. So the OSPF link cost is calculated by default with a reference bandwidth, and that reference bandwidth is 100 megabits per second. With 100 megabits per second, so that's 100,000 bits, with just 100,000 plain, not 1024 or any of that stuff, but it's 100 megabits. It'll divide that into the interface bandwidth amount. So you'll get 100,000 bits divided by the interface bandwidth. And that's a problem somewhat, because you'll run into these sort of situations where if you don't set the bandwidth correctly, it will route you a slower direction. You still get there, but it might not be the best way. It also is a problem when you get into the faster speeds, because this was designed before gigabit existed. So remember I said OSPF started around the 1980s and then kind of got kicked into gear in the 90s, and so it wasn't around before when gigabit was invented. So when you divide that out, you get a value of 1 for 100 megabits, and you can see that here. We're at the central router, and if we want to get to the 1 dot network, which is up here, we have to go through a cost of 2. So that means this link is a cost of 1, and this link is a cost of 1, and then it adds them up. The problem being, let me get back to this, there we go. The problem being, it's designed with fast Ethernet in mind. Remember I said the reference bandwidth is 100 megabits. So these are 100 megabit connections because these are fast Ethernet connections. So when you do 100 meg divided by 100 meg, you get 1. If this were a gigabit connection up here, then you would do 100 meg divided by 1000 meg, you'd get 0.1, but then it rounds it up to the next largest integer. So then you get 1 again. So it doesn't know the difference between 100 meg and a gig. So that's something that you can go in and fix. You can tweak that. You can change the reference bandwidth, which I'll show you. But it also just drills home the idea of make sure your bandwidths are correct, especially on serial interfaces and things that can be a little bit different, like frame relays and such. You pay for a certain amount of speed. It's going to assume a T1 connection. It's just going to say, you didn't tell me, so it's probably 1.5 meg. Odds are nowadays it's not 1.5 meg, so make sure you set that correctly. So we have these routes up and running, and on this central router I made that fake, I have this fake static route saying my default gateway, my gateway of last resort goes up through router 3 and beyond. So that's going to be my pretend internet connection or something like that. I want to redistribute that through my OSPF network so that everyone else knows that they can come talk to me at router 0 in order to get out to beyond our local network. So in order to do that, it's the same command as RIP. We can do default information originate. I like this command. I just think it makes sense. You enter it, and now it's going to spread 0000 to the other routers. So now they'll know about it. We show IP route, and now instead of saying R with an asterisk, we have O with an asterisk, and it's saying it's an external route, and it's available through this interface, and then it'll go on to wherever it needs to go. So that's your way of sharing out and redistributing your gateway of last resort. When we get to egrip, you'll see that that's not the case, and it's a little bit weirder. So RIP and OSPF have their act together, and that's actually very nice. There's other things you can do, such as modifying the hello interval and the dead interval. You can do that. I wouldn't necessarily suggest it, but remember how I was talking about you can change the priority on an interface so that it becomes the designated router. You can do the hello interval and dead intervals per interface as well. So if I was in FA01, I can do IP OSPF, and there's actually a bunch of different commands here, not just priority. And you can change the cost as well, not just set the bandwidth of an interface with the bandwidth command, but I can actually force a cost just for OSPF. I would suggest just doing the bandwidth, but that's up to you. But anyway, we can do IP OSPF and then change the hello interval to X number of seconds, whatever we want, 5 seconds or something. Would you really want to do that? I'd say leave things as default, but that is there for you to tweak if you do wish to tweak it. There are 3 different types of authentication that is supported by OSPF as well. And you see some of that actually here in the interface. You have to configure it on the interface. We have no password authentication, which is how it is now. It's just sharing things and it's a-okay. We can do a password-based authentication. There's an MD5 method where it makes a hash. And then with OSPF version 3 is a little special. It does not have any of that built in. But it relies on the native built-in IPv6 abilities to do IPsec. So that's actually kind of nice because it doesn't tack anything else in there. It just says if you want security, do it with the built-in methodologies that we have with IPv6. And IPsec is very powerful, so that's nice. Alright, so let's do, since we're talking about it, let's do, I am on router 0, so yeah. We can do IP OSPF, and we'll set authentication. There we go. Set a message digest, and that'll make it MD5, and then we can set the key. This will change based on the version you're on. Sometimes it'll say IP OSPF authentication. Sometimes it'll say IP OSPF message digest key, stuff like that. They've changed things over time. So what we'll do is guess we'll do 1, and then we'll just come up with some sort of key. And then we'll go into the area. And that would enable it in our area. So you can go ahead and configure that and set up authentication if you like. That's, in my experience, it's not something I've seen often used, unfortunately, but that's something certainly would suggest to be done. There's a number of show commands that can be done. And you know what, let's go into, see, now it's all angry because I started authentication. Let me fix this real quick before I get into show commands. Gotta give it a sec. I'm going to go into the interface too, and we'll go fix that. Alright, there we go, it's coming back up. I'll just let that sit. But there's some show commands that are very useful to you. We have ones such as show IP OSPF neighbor, which will show you all those neighbors that have been connected to and put into your adjacency table. And you'll see here, I'm on the main router 0, so it doesn't tell me that I'm the designated router in this display, but it tells us what the states are of everyone else. So we have our backup designated router, which happens to be switch 1, it looks like, as well as their IP information and the last time they've been spoken to, and their neighbor ID. So remember I was talking about the ID? Here's where that comes in. So that's your identifying number for that the router. So I didn't configure any on them, so it just chose the highest IP on those interfaces available, and that was the 192 address. And if we go into router 1, we can see that from the other side. So now we can see his ID is much higher, so that was the one I configured. There's also show IP protocols. So it'll give you some verbose information about your OSPF instance and some of the different options that you have turned on, what routing is enabled for what areas, what the largest path is, how many areas you have, and so on. If you just do show IP OSPF, that'll give you additional information, very verbose, detailed information for diagnostics. And then you can do it also based on per interface. Sometimes you can also execute interface brief, which will give you kind of like a nice printout of that type of information in a brief format. This one doesn't support that though. You can also do show IP route, but just OSPF. And then we can also clear. Oh, I'd have to do that from here. Okay. Again, some of them require you to define which process number. Okay, so now it wants to know. Huh, interesting. Okay. So I can basically force a restart of OSPF on this. So you can see it cleared out everything, and now it's starting from scratch again as if it were a new network. And it's coming back up again. So that's the basics of doing a single area OSPF, and I managed to kind of break things along the way as we were fiddling with authentication, but that's alright. IPv6 with OSPF version 3 is pretty much the same deal. If you want to do authentication, you do so with a different command, which would be IPv6 OSPF authentication IPsec SPI, and that'll tell it to use the built-in IPsec option for IPv6. Another different thing with OSPF version 3 is pretty much all the commands in it, and you'll see this with a lot of things in the Cisco routers. Version 4 starts with IP, and then version 6 starts with IPv6. So if you're trying to get into OSPF version 3, it's IPv6 router OSPF, and then whatever process ID. So you'll have to just get used to appending v6 to all of your commands if you're in a v6 environment. Same with the show commands. So all those show commands that I was doing, they were you also would do show IPv6 OSPF, show IPv6 protocols, and so on. They would all be the same.